Welcome. In this problem, we have a circuit with a 9-volt source and a 5 amp current source. We are asked to find the voltage across the 10 ohm resistor, uh, VAB, and the current through the 10 ohm resistor as indicated by the current direction from A to B, IAB and VAB. Right, there are a number of ways to solve this particular problem. Uh, in this video, we will look at node voltage analysis method to solve it. Okay, so let's start out by arbitrarily defining a number of currents that flow through the different resistors. So I'll call those I1, I2, I3, and I4. So let's start with those. So I have I1, I2, I3, I4 uh, labeled. Now we have a reference node right here given down at the bottom. So that's a ground node right there. So that's a reference node. Now because that is ground right here, and there's a 9-volt source right here, we can immediately say that this side of the voltage source is at 9 volt with respect to that reference. So this top portion right here, all of that is going to be equal to 9 volts. So now we have two important nodes, node A and node B, also called essential nodes, A and B. We'll do Kirchhoff's current law at each of these nodes. So let's start out with a KCL at node A. And when we do Kirchhoff's current law at node A, the amount of current flowing into A is I1, and the amount of current flowing out of A is I2 and IAB. So Kirchhoff's current law says current coming in equals current going out. So I1 equals I2 plus IAB. Now I1 flows from 9 volt node towards A through the 12 ohm resistor. So I1 can be written as 9 minus the voltage at node A divided by the resistor 12 ohms using Ohm's law. Similarly, I2 can be written as 9 volt minus the reference node 0, VA minus, sorry, not 9 volts. I2 can be written as node A, VA minus 0 divided by 16, and IAB can be written as VA minus VB divided by 10. So let's rearrange the voltage sources so that we have the voltage is written as such. So VA 1 over 16th from here, VA 1 over 10th from here. Let's bring this on this side, so VA 1 over 12th. That's how we got this. Similarly, VB has only one place right here, so negative 1/10, and we have 9 over 12th from this constant on the right hand side. Okay. Similarly, if we apply Kirchhoff's current law at node B, we see that the current going into node B are IAB, I3, and the current coming out is I4. So the sum of those should all equal. And we also have current 5 amps coming into node B. So I3 is coming into B, IAB is coming into B, 5 amps is coming into B. The current coming out is called I4, so that's why we have I3 plus IAB plus 5 equals I4. I3 is 9 volt minus VB divided by 12. IAB is VA minus VB divided by 10. We have 5 amps as is, and I4 is VB minus 0 divided by this 16 ohm resistor. That's what we have here. Now we'll rearrange VA and VB just like what we did in node A analysis. So after we do that, what we end up is with this expression right here. Now these are simple enough expressions with two unknowns and two variables. So we could basically simplify them using basic algebra, but in order to gain practice with MATLAB, what we'll try to do is write these linear expressions as a matrix and then use MATLAB to solve them. So let's do that. So let's write those as matrix. So here it is. So I have 1/16, 1/10, and 1/12 added together. So that's what that is. Minus 1/10 for VB right there, and VA, VB. So when you do matrix multiplication, this basically reads VA times this plus VB times this equals this part right here. Similarly, VA times this plus VB times this bottom part right here equals this portion right here. So that's where these come from. Okay. Now once I have that matrix, I'm going to fire up MATLAB, and here's my, I'll call that alpha, variable alpha, and on MATLAB, I'll write that as following. So alpha is 1/16 plus 1/10 plus 1/12, comma, minus 1 over 10 to indicate a new column. To indicate a new row, I have a semicolon right here and 1/10, so that's 1/10 right here. And the next next item can be written either as a comma or a space because that's how MATLAB columns are designated. So that's what I have. So if I hit enter here, I should see the value of alpha calculated. Now next, let's call the right-hand side expression right here. This is part of the matrix. Let's call that a y and write that part in MATLAB. So y equals square brackets 9/12 semicolon, because we're starting a new row, minus 9/12 minus 5. And in order to calculate v, this thing right here, we'll call that v. Okay, in order to calculate that, we'll call that v. We can do alpha backslash y, or we can do inverse of alpha times y. So v equals alpha backslash y, and we get v equals 15.0568 and 29.5146. That's way too many decimal places, so we'll just write down VA is 15, VB is 29.5 volts. Okay. Now, we were initially asked what is the voltage across the 10 ohm resistor VAB and the current through it. So VAB is VA minus VB. VA minus VB leads me to negative 14.5 volts. Now we don't have to worry that the voltage came out to be a negative value. All that means is that the indication of the current we had, the direction of the current we had up here for IAB this way, in real circuit the current is actually flowing in this way. That's what that means. Okay, that means VB is at a higher potential than A, and that's what we're seeing here. That's why we're seeing a negative voltage for that. Similarly, IAB is VA minus VB divided by 10. So VAB divided by 10 is negative 1.45 amps. Okay, so just like for the voltage, not to worry about the fact that the current came out to be negative. We are okay there.